Okay, today is October 24th, 2011. We're on lesson 3.7. This is kind of a wrap-up. We're going to review and talk about all the information that you guys would have done on those 3 assignments. First thing we're going to talk about is positive and negative correlation. I need to make sure you guys know the difference. So positive, let me make sure I spell this right. There we go. And negative. So, many of you guys would have done those assignments this weekend, and possibly you had some data when you plotted it on a scatter plot. Looked something like that. If our line of best fit goes upwards and to the right, this is considered positive correlation. Okay? The reason we know it's positive, we're going to get into a bit later, because I still need you guys to go back to what you learned in grade 9, is we're going to have to know the equation of this line. Way back when, you guys would have learned y equals mx plus b. The positive is referring to our slope, our m. If the line ends up going in this direction, our slope will be positive. And we're going to find the equation of that line in a little bit. So that's how we're going to know that it's a positive correlation. All right, our second example is a negative correlation. Possibly when you plotted your data, you may have found something like this, where all of the data seems to go in a downward slope. In that case, we're looking at a downward slope, which means we have a negative correlation. So it doesn't mean that it's bad. Negative has nothing to do with it being bad, and positive has nothing to do with it being good. They're talking about the slopes of these lines. So again, the formula for a line is y equals mx plus b. Positive and negative refer to the slopes of those lines. So this is a negative correlation. All of the information or all of the data heads in a upwards to downwards direction when we're going from left to right. So if we're reading, we always read from left to right and assume we're in English, okay? If we're reading, we're going left to right, and the information seems to go downwards. That means we have a negative correlation. If I'm going from left to right and the data seems to go upwards, I have a positive correlation. Okay. You guys on your assignment may have plotted data and it started to look like this. If we were to make a line of best fit, it'd probably be something like this. But if you notice, a lot of the data falls pretty far away from this. It does seem to slope upwards and be positive, but the data is very spread out. Okay? What that means is you guys have a weak correlation in the data. Okay? So the data does tend to be positive from what we found out, but the problem is it's not all put together around one specific line. Our line of best fit is generally the best line of fit, but really I could have made several lines of best fit. Maybe the line would be more accustomed to being up here, possibly down here. Okay? We estimated our line of best fit, and because it's not exact and it looks like the data is very spread out, we have a weak correlation in our data. Okay, you may have graphed data that looks like this, and we can fit a line of best fit almost perfectly through this. All of the data is very tight around the line of best fit, so we're going to call this a strong correlation in the data. The data seems to be all falling almost perfectly on the line of best fit. We have a strong correlation in the data. Okay? Okay, we've changed from dots to smiley faces now just to capture your interest. But say you were plotting data, and again you had points all over the graph like this. A line of best fit is very hard to estimate here. I might say this is a line of best fit, but it doesn't look great. Maybe it's a negative correlation in this data. I really can't tell with my line of best fit. Maybe it's completely horizontal. None of these seem to actually fit perfectly. So what ends up happening is it looks like there is what type of correlation? Anyone know? Bad. What's another word for that? Starts with an N. No correlation. Hey. There is no correlation. No, a negative correlation is sloping downwards. We just learned about that. Yeah, he wasn't paying attention to that. Okay, so let's go back to our first set of data. Remember I told you this was a positive correlation. What I need you guys to do, thanks, Jordan, is we need to actually find the equation of the line of best fit. So we talked about linear equations being y equals mx plus b. So this is where we get the hard part. You've estimated your line of best fit, and everyone's estimation is going to be a little different, but you need to be able to give the equation of the line of best fit. So we're going to go through working through that right now. So we use y equals mx plus b. We know m is the slope of the line, and b is the y-intercept. Okay? In order to find the line of best fit, especially with the types of data we're working with, we're all in the positive region, I need to actually find coordinates on this graph, and I'm going to try to be as exact as possible. So, let's start with this point here, which is on our line of best fit. I would say that this point here is roughly 1.5 and 2. Okay? In order to actually get the equation of the line, I'm going to need 2 points along this. So again, I'm going to try and find another point that I'm going to work with probably whole numbers. Here's another one. This point here. And it doesn't have to be the beginning and the end of the line. They just have to fall anywhere along the line. This point here is at 5.5 and 6. Okay? So I'm going to call this point 1 and this point 2. Now there's a formula I need you guys to remember from way back in the day. It is slope formula. Anyone happen to know it? Rise over run. Okay, we'll start with that. Rise over run. And we'll talk about the 2 ways to get this information. Okay? First, if you've actually graphed it, you could count upwards. So our rise here would be 1, 2, 3, 4. So, to find the slope, we could count on the graph like we just said. From point 1 to point 2, we moved up 1, 2, 3, 4 points. And we moved to the right 1, 2, 3, 4 points. So we went 4 and 4. We went up 4 and to the right 4, which is positive 4. Okay? But sometimes on our graph it's really hard, especially if we're in between our whole numbers to tell. So I'm going to show you using actual formulas in order to solve that. So rise over run, which is the same as y2. This is the important formula. Put it in red. Subtract y1 over x2, subtract x1. So, in order to do that, I write my first point. We'll call it point A. It doesn't matter which one you call point 1 or point 2, as long as you're consistent. It'll still work out. And point B is 5.5 and 6. Okay? So that was our point 1 and point 2. I numbered them purposely because of the formula. Okay? These aren't exponents. This would be what you call on the computer subscript. So it's just telling us that I'm using the y from the second point and the y from the first point. So what I'm going to do is I'm actually going to name each of these points. Because this was my point 1, this will be my x1, and this will be my y1. Since this is our second point, x2 and y2. It'll help you a lot in organizing the formula if you put x1 and y1 on top of your coordinates. Okay? Now I'm going to plug them into the formula we had. y2 subtract y1 over x2 subtract x1. So my y2 was 6. Subtract y1 was 2, divided by, so remember this is our slope, m equals, x2 is 5.5, and x1, subtract x1 was 1.5. We're going to subtract those numbers. 6 subtract 2 is 5.5, subtract 1.5. Hey, very good. And 4 divided by 4 is positive or negative? Positive. So that goes right back up to our original information. We knew this was a positive slope. The slope of this line is 1, but I'm not done. I've only found the slope of the line. So, again, our equation of the line was y equals, we knew m is equal to 1. So again, our formula was y equals mx plus b. Our m was 1. But I still need to find point B, and this is where it gets tricky. So in order to find point B, I'm going to need a coordinate from our graph to plug in a value for y and x. Luckily, we have 2 coordinates, and it doesn't matter which one we use. So I'll use the second one just to prove it. Our second coordinate, coordinate B, was at 5.5 and 6. That would be my x and my y value. I'm going to replace the x in the equation with 5.5 and the y with 6, and then I'm going to solve for b. So our y is 6. We've now replaced the y with the number 6, is equal to 1 times x is 5.5 plus b. Okay? I need to isolate for b. So 6, 1 times 5.5 is 5.5 plus b. When I move 5.5 to the other side, what does it become? Negative. Good. So I end up with 6 subtract 5.5 equals b. What's 6 subtract 5.5? 0.5. B. So, again, our equation of our line is written y equals mx plus b. Y equals, m was 1, x and b was 0.5. So our equation of the line we had above is y equals 1x plus 0.5. Okay, so I gave you guys 2 pieces of data in this graph. We have our 2 coordinates, and again, we need to find the slope and y-intercept. So remember that formula I gave you guys, y2 subtract y1, whoop, that's not a 1, divided by x2 subtract x1. This is our m, or our slope. So we're going to plug our coordinates in right now. M is equal to y2, x2, x1, y1. Remember, your first coordinate is always your x. Our y2 is 3, subtract y1 is 8, divided by x2 is 16, x1 is 4. We have our points, we just carry this out. 3 subtract 8 is negative 5, and 12. So our slope, turns out it is a fraction, is negative 5 over 12. So our formula again, y equals mx plus b. This was our m, negative 5 over 12. So we're going to replace m with negative 5 over 12. X plus b. And remember, I told you, in order to find the b now, we need to know one of the coordinates on the graph. Luckily, we already know 2 of them, because we need to plug in their x and y value and then isolate for b. So I'm going to choose 4 and 8. We'll take point A. So point A, 4 and 8. x was 4, y was 8. I'm going to plug 8 in for y and 4 in for x. 8 is equal to negative 5 over 12 times 4 plus b.
Yeah, negative 20 over 12.
8 is equal to negative 20 over 12. You can reduce the fraction, it's fine. So maybe, I'm going to put or, if you've reduced the fraction, you have 8 is equal to negative 5 over 3.
So would you
Okay, so I'm going to solve this two different ways now. The first way, I'm going to eliminate the fraction. Okay, so this is called our eliminating the fraction. So I'm going to solve this one by eliminating the fraction. In this one, I'm going to solve using fractions. You can use either way. If you know another way you could use it, I just want to model two different ways so you get used to using whatever's comfortable. So I have a fraction here, the number 12. It's only one fraction. Everything else is technically over 1. I want to get rid of this fraction, 12. So because this is a division sign, if I multiply the entire fraction by 12, it will eliminate the 12 on the bottom. Okay? So I'm going to multiply everything in this by 5. Sorry, 5. By 12. Sorry, guys. So that means I'm going to multiply 8 by 12. I'm going to multiply this fraction by 12. And I'm going to multiply b by 12. b12, that's right. So 8 times 12, 96, is equal to, when I multiply this fraction by 12, what's going to happen? That's right. The 12 on the bottom and the 12 I multiply by will cancel out. We'll just be left with negative 20, the top part of the fraction. And when I multiply 12 by b, we get 12 times b. Now I'm going to move the 20 to the other side of the equation. It's going to become positive over there. 96 plus 20 equals 12b. 96 plus 20 is 116 is equal to 12b. And in order to move that 12 over, I got to divide by 12. So I get 116 divided by 12 equals b. You can leave it as a fraction if you like, or I know most of you guys aren't comfortable with the fractions. So you can turn it into a decimal. 116 divided by 12, 9.67, okay? Say we round it. So we get 9.67. So our equation of the line y equals b. mx plus b. Our m was negative 5 over 12. Where did we solve that? Up here, right? There it is. Negative 5 over 12 is our m. So y equals negative 5 over 12 plus either 116 over 12, or if you decide to use decimals, you would have got y is equal to, if we do 5 divided by 12, 0.417. So negative 0.417x plus 9.67. So if you guys notice, our decimals were odd numbers, but that's fine. They're still legitimate. Or you could left it in fraction form. Either one was acceptable. You could have either the decimal form or the fraction form. Not one of each, one or the other. Okay, so we solved it using the elimination method. The other way we could solve this is keeping everything in fraction form. Okay, so that means we needed to isolate the b. And I'm going to move this fraction to the other side of the equation. So I would get 8 plus 5 over 3 is equal to b. Now, here's where we run into trouble with fractions. I can't just add these two numbers together because their denominators are different. This is technically 8 over 1. So I need to turn 8 into a fraction that has a denominator of 3. So in other words, I need to multiply the top and the bottom of this fraction by 3. In this case, we'll get 24 over 3 plus 5 over 3 is equal to b. When we add the two fractions together, the denominator still stays as 3, and 24 plus 5 is 29b. Okay? So again, our answer could have been y equals negative 5 over 12x plus 29 over 3. Or if we put it in decimals, we're going to end up with the same answer. 29 divided by 3, 9.67, just like we said before. So we get y equals